some compound inequalities. So I'm going to solve each one of these just like I did the previous ones. Then when I graph the compound inequality, I have to take into account the truth of each statement. So I'm going to minus 5. That gives me 4x is less than negative 2. Divide both sides by 4. And I don't flip it because I divided by a positive. So that's less than 1/2. And then this one I'm going to add 2. I get 3x is greater than or equal to 3. Divide both sides by 3. And I get x is greater than or equal to 1. So from a negative 1/2 and a 1. This inequality says that x is less than negative 1/2. This inequality says that x is more than 1. So this is actually the resulting graph. Because it's an OR, you're allowed to have them point opposite directions. Alright, so here, a whole bunch of work on each one of these. This is another OR problem. I am going to, in an effort to keep everything positive, I'm going to subtract 3a from both sides here. So I have 2 is greater than or equal to 2a plus 4. Subtract 4 from both sides gives me negative 2 is greater than or equal to 2a. Divide both sides by 2, and I have negative 1 is greater than or equal to a. I don't graph that yet because I don't know whether my other one's going to work out to be more or less than negative 1. So here I'm going to distribute first. So 2a plus 6 is less than 7 plus 3a. Now I'm going to subtract 2a from both sides. And I get 7 plus a is greater than 6. Minus 1 from both sides, and a is greater than negative 1. So I have a is, that's interesting, did I do that right? Minus 4 gives me a negative 1, alright, and then distribute, minus that. Yep, did it right. Alright, so whenever you get a weird answer, like I got a negative 1 here, negative 1 here, it makes me a little nervous, but double check your work. If you do your work out alright, and that's correct. So a is less than or equal to negative 1. So we got negative 1 here. That would give me this graph, less than or equal to negative 1. This gives me, this one here gives me a is greater than negative 1, which would point that way. Since it's an OR problem where one or the other of these needs to be true, all the numbers under this and all the numbers under this work, so this is an all real numbers problem. Because every number on the number line would be true for this or that.